In exercise 303, we look at the area of shapes which have a curved edge, and they basically come from the circle. So we start with the area of a circle being pi r squared. Now, I'm not going to look up your formula sheet. You have to look up your formula sheet and identify which of these are most importantly, well, actually, it goes both ways. You have to know which ones are on the sheet so that you can use them and don't waste your time learning them off by heart. But you also have to have identified those formulas which you are possibly required to use which don't appear on the formula sheet, and they are the ones you will have to learn. Now, hopefully you've done some things like I've been suggesting, writing things on pieces of paper, putting it above your desk, and having them there, seeing them every day will help you to learn them. Hopefully you've been doing that with other things that you've had to learn, and you're going to come across more formulas that don't appear on the formula sheet, but you will be required to use them. So please do these exercises, this exercise in particular, 303, with your formula sheet beside you so that you know which of these formulas are on it and which are the ones that have got to go on your piece of paper that go on the wall for you to learn. Area of the triangle, pi r squared. An annulus is this region between two circles that share a common centre. The outer circle will have the largest radius, and we refer to that as capital R, and the inside circle has the smaller radius, and we use the lowercase r. And for those of you that want an understanding of where this formula comes from, it actually came from saying that the shaded area would have been originally the area of the bigger circle, which is pi r squared, but that's been too much. What's been taken away from that is the area of the small circle inside, which is pi little r squared, and then the process from this line to this line is called taking out a common factor. Now, some of you who have done more algebra than is required in this course, maybe in stage 5 you did it, or you might have started in the advanced course and dropped into the general course in stage 6, you will know this is factorising, where you take the pi out and you're left with capital R squared minus R squared. Now, again, I'm not checking with the formula sheet. You have to know whether this is on the formula sheet or not. So if you didn't get it out and have it beside you, then please do now. See whether this formula is on it or not, and make a note to yourself as to where will you be accessing it on the formula sheet, or will you be accessing it from your memory if you get a question asking you to calculate the area of an annulus. A sector is only part of a circle. You need to be aware of the size of the angle at the centre. That over 360 creates what fraction of the actual circle that we've got, and we introduce that as part of the area of the circle. So we only want a fraction of the area of the circle. A semicircle is exactly half a circle, so that fraction becomes a half, or the angle at the middle is 180 degrees, and 180 over 360 simplifies to a half. If you're unsure of that, then also have your calculator beside you and do the fraction 180 over 360. Press equals and you'll see that that's a half. So this formula is in keeping with this one up here. then you will have also a quadrant where your angle at the centre is now 90 degrees and 90 out of 360. Again, take your calculator and actually put that on your calculator and press equals. You'll see it simplifies to a quarter. Let's have a look at these examples, and I will yes, I'll leave that example 2 to do in class. So I think in this video I'll have time to get through these. The circumference refers to the length around the circle, the circumference. Please, I'm pretty sure that's not on the reference sheet. But either way, please make sure you check to see whether it is or not. It can be written in 2 ways. The circumference can be known as 2 times pi times the radius, or the circumference can be known as just pi times the diameter. Now I would say you would use this one if the diameter was given in a question, and you'd use this one if the radius was given. And you know the difference between the diameter and the radius. The radius goes from the center across to the circle, and the diameter goes right across the circle and through the center. An arc forms part of a circumference. So this, if we just wanted this little bit from there to there, or from A to B, that is called an arc. And I've actually indicated here that it is on the formula sheet. So please find it and write arc length equals, and you write what it is. Okay, let's have a look at this example. An annulus has an area of 392.70 square meters. Calculate the inner radius of the annulus. If the outer radius is 15, answer correct to the nearest whole number. Okay, this is clearly a problem. Now, some of you are wondering what you can do in an exam to improve your exam technique. Please take notice of this. I would like to see you highlighting or underlining. So practice it now. Pause the video, take a pen and start to underline what's important in this question. As you can see there, I've circled annulus. Why? Because there's a formula for the area of an annulus, and at this stage I would write that down. The area is equal to pi times big R squared minus little r squared, and I might also draw it. It's good enough for an annulus, and it is this shaded area. These 2 circles have the same center, and that clearly have got different radius. It says the annulus has an area of 392.7. This shaded bit, area is 392.70 meters squared. We actually know the area. So unlike the standard question where you're asked to find the area, in this question you're given the area. That's really important to register that. And the more time you spend at the beginning identifying the information that's given in the question, the more likely you are to have registered it. If you approach these questions just jumping in, doing what you did in the question before or the last time you did one of these, then you're possibly making a really big mistake. Not every question is going to be the same. You have to get away from that mentality and start to think, I have to take every question for exactly how it is. I have to spend time reading, understanding what's given in this question and what I'm being asked to find, and realizing that's not going to be the same for every question. I've also, you can see I've underlined calculate. I've been asking you to look for the word find in the wording. Find, calculate, what is. They're keywords to be identifying and looking for them in a question. That tells me that I need to find, it says the inner radius. What's my understanding of that in terms of the maths? Well, clearly here in terms of the diagram, I can see it's this. And then I realise that in this situation, that is called lowercase r. So in my formula, I'm going to be finding lowercase r. If the outer radius is 15, I can identify that capital R is 15. Now, this is all looking good because I know that in a formula where we've got 1, 2, 3 possible unknowns, and pi is not an unknown. Pi is a number. It's not an unknown. So 3 possible unknowns, I could be required to find any one of those 3 unknowns. And obviously I am. I'm finding this R, which means I must be given A and I must be given capital R. I know that algebraically, but I've just been through a process where I've also identified it from the question. So I'm going to pause the video because it's getting a little bit long and write the solution and come back and talk about it. Okay, you can see there I have substituted into the formula, sorry, and then basically solved the equation. Again, it's probably a good idea if you, at this stage, if you haven't had a go at doing this, pause the video and you even write it out in pencil in your notes. Have a go at solving this equation. Then restart the video and have a look at what I've done, and hopefully you will have the same. I'm going to focus more on the calculation for R, taking the square root and getting it into this calculator. So you can see I've got straight out what I've written here, which is really nice. The calculator reflects that exactly. So if you've gone through this process of every line showing every step, then you can type this straight into this calculator. I'm just going to press equals, and we're getting 9.999. So I've written 9.999, and just as well I've highlighted this, which says give my answer correct to the nearest whole number, and I round that up to 10. Like I said, I'll leave example 2 for class, and I'll do that with you there.